Hello students, you are welcome to the Rock Tutors Learning Made Easy. I am your chemistry teacher. Today we'll be looking at some questions in chemistry. And please don't forget to subscribe, to like, to share our videos, and also endeavor to put on the notification bell so that you'll be notified when a new video like this is uploaded. Let's look at the very first question. Number 1. The maximum number of electrons that can be accommodated by K shell is, we know that there are various shells. Shells are circular orbits that surround the nucleus. If you take a look at an atom like this is the closest shell to the nucleus, that's the K shell. Next to that is the L shell. Next to that is the M shell, N, and so on and so forth. And for K shell, the principal quantum number for K shell is 1. So N is equal to 1. For L shell, N is equal to 2. For M shell, N is equal to 3. And don't forget, there is a formula that is used to calculate the maximum number of electrons that can be accommodated by a principal shell. And that formula is 2n squared. And since I'm talking about a K shell, we know that for a K shell, the principal quantum number is 1. So if you substitute here, that becomes 2 into 1 squared. 1 squared is definitely 1. 1 multiplied by 2, that's 2. So the maximum number of electrons that can be accommodated by a K shell is 2. That's option A. Let's go to number 2. Number 2, the general gas law is derived from the combination of... Now, if I think about the general gas law, this is what we're talking about. PV is equal to nRT. So, which of the laws, which of the gas laws are combined together to give us this? 3, actually. From Boyle's law tells us that the volume is inversely proportional to the pressure. That's 1. From the chassis law, the volume is directly proportional to the temperature. That's 2. And then from the Avogadro's law, the volume is directly proportional to the number of molecules. That's 3. Now, if you combine the 3 of them, we end up with something like this. Volume directly proportional to this, multiplied by this, multiplied by this. So that gives us Tn or Nt. Nt all over P. Now, if you introduce a constant, then we now have something like V is equal to K Nt all over P. And if you cross multiply, we end up with P times V. That's PV is equal to K Nt. And this particular K here is the gas constant. So in essence, there are 3 laws that are combined together to give us the general gas law. And the 3 laws, as can be seen on the board, are Boyle's law, that is represented by this, the Avogadro's law, represented by this, and the chassis law. Number 3, under what conditions do real gases behave like ideal gases? So, real gases only behave as ideal gases when the pressure is low and the temperature is high. So, the 2 conditions are high temperature and low pressure. And taking a look at the options, the correct answer here is option B, at high temperature and low pressure. So real gases behave as ideal gases at high temperature and low pressure. So that's for that. Don't forget that also at high temperature and low pressure, gases do conduct electricity. That is another question you can come across. You could be asked questions like, under what conditions do gases conduct electricity? Gases conduct electricity at high temperature and low pressure, or at high voltage and low pressure. So the correct answer for number 3 is option B. Let's look at number 4. Which of the following statements is correct about the electrolysis of concentrated CuSO4 solution using copper electrode? Let's look at what happens when SO4 solution is electrolyzed. This decomposes to produce copper 2 ion and sulfate ion. And don't forget, since there is solution, this is in solution automatically, it means it is dissolved in water. So the water also dissociates to produce hydrogen ion and also hydroxide ion. Now, the cations here will migrate to the cathode at cathode. But we know that out of the two of them, hydrogen ion and copper 2 ion, only one of them will be preferentially discharged. The question now is, how do we know which of them will be preferentially discharged? Now, there are three factors that affect preferential discharge of ions during electrolysis. Number one is the position of the ions in the electrochemical series. Number two is the concentration of the ions. And number three is the nature of electrode. And the electrode being used here is copper electrode. Don't forget, copper electrode is an example of active electrode, which means it's going to take part in that chemical, in this chemical reaction, in this electrolysis. And what happens here is the hydrogen ion and the copper 2 ion, both of them migrate to the cathode. But because copper 2 ion is lower than hydrogen ion in the electrochemical series, it will be the one that is discharged. It will accept electron. The copper 2 ion will accept electron. We accept 2 electrons to become deposited as metallic copper. So which means copper is lost from the solution. Also, the 2 anions will also migrate to the anode at anode. But since we are using copper electrode, which is an active electrode, none of the sulfate ion or the hydroxide ion will be discharged. Instead, it is the copper anode that will dissolve. At the anode now, both sulfate ion and hydroxide ion will migrate to the anode. But because we are using copper electrode, so which means both the cathode and the anode are made of copper, none of the anions will be discharged here. Instead, it is the copper anode that will dissolve to produce copper 2 ion and liberate 2 electrons. So essentially, what is happening is there is deposition of copper. Copper is being lost at the cathode, and the copper that is being lost at the cathode is being replaced at the anode. So the reaction occurring at the cathode is deposition, and the reaction occurring at the anode is dissolution. So the copper lost at the cathode is replaced at the anode. So which means that the concentration of the electrolyte will remain unchanged because the copper that is lost at the cathode is simultaneously being replaced at the anode. So the correct answer here is the concentration of the electrolyte is unchanged, or the blue color of the solution will remain unchanged. So the correct answer for number 4 is definitely option A. Let's go to number 5. The application of electrochemistry in which a sheet metal is coated with a less reactive and most often more expensive metal is that is electroplating. The spoon we are using at home is made of iron, which is a sheet metal, but it is coated most of the time with silver to protect it from corrosion. And that process of coating that particular metallic spoon with silver or with chromium or any other, even at times some cutlery are coated with gold and so on and so forth. That is a process called electroplating. And it should be noted that during electroplating, the material to be electroplated is made the cathode, while the electroplating material is made the anode. So the correct answer for this is option D. Don't forget that electroplating is also one of the ways of preventing rusting. Let's go to number 6. The oxidation number of ion in the complex, this particular complex is dash. Let's look at how to tackle this. This is the complex. So we can see that the overall charge on this complex is -3. So we are going to equate everything to -3. We need the oxidation number of ion. So this ion plus the oxidation number of cyanide is -1. So that's going to be -1 multiplied by, there are 6 cyanide, multiplied by 6. Everything is equal to the overall charge on this ion is -3. So we put -3 here. Then here we now have Fe Plus times minus, that's minus. 1 times 6, that's 6, is equal to minus 3. And then Fe, if it takes minus 6 to the other side, it becomes plus 6. That becomes minus 3 plus 6. And then Fe now is equal to plus 3. So the oxidation number of iron in this complex is plus 3. Let's go to number 7. The most electronegative element on the periodic table can be found in, there are 118 elements in the periodic table, starting with hydrogen and ending with oganesson. And out of these 118 elements, the most electronegative element is fluorine. The question now is, in which group is fluorine found? In which period is fluorine found? Fluorine is the first element in group 7 in the periodic table. Remember that group 7 is famously referred to as the halogen group, and it is located in period 2. So the correct answer is going to be group 7 and period 2. And if you look at the option, the correct answer is C, group 7 and period 2. As a matter of fact, it is easy to know which group and which period any element belongs to. What we need to do is this. Since we know the element being spoken about here is fluorine, this is fluorine with atomic number of 9. And this can be broken down to 2, 7. 7 here is the number of valence electron. The valence electron of an atom shows the group it belongs to. So 7, that's group 7. And the number of shell gives the period it belongs to. 1, 2. This is the K shell and this is the L shell. So it has 2 shells. That is period 2. So it's as simple as that. The number of valence electron gives the group and the number of electronic shell gives the period. So that's option C. Let's go to number 8. The position of equilibrium in a reversible reaction is affected by dash. Particle size of the reactant. The particle size of the reactant does not affect the position of equilibrium. Change in concentration of the reactant, obviously, that's the correct answer, because there are actually 3 major factors that can affect the position of equilibrium in a reversible reaction. Number 1 is the concentration of either the reactant or the product, the pressure of the reactant, and also the temperature of that particular reaction. So we can see that change in concentration will definitely affect the position. An increase in concentration of the reactant will shift the equilibrium to the right, whereas an increase in the concentration of the product will shift the equilibrium to the left. So the correct answer here is option B. Let's go to number 9. The amount of heat energy produced by a system is known as dash. That's the enthalpy. We refer to enthalpy as the heat energy that accompanies a chemical reaction. It can be the heat that is released during an isothermic reaction. It could be the heat that is absorbed during an endothermic reaction. So the correct answer for number 9 is A. If I look at B, B is entropy. Entropy, simply defined, is the measure of the degree of disorderliness or randomness of a chemical reaction. And if I'm talking about exothermic reaction, it is a reaction in which heat is released or liberated to the environment, whereas endothermic reaction is a reaction in which heat is absorbed from the environment. But the question is asking us, what is the amount of heat produced by a system? That is the enthalpy change, which is option A. Let's go to the 10th question. How many moles of hydrogen chloride are formed when 1 mole of methane reacts with excess chlorine in sunlight? Let's write a simple equation for it that will give us the answer in a simple way. How many moles of hydrogen chloride, that's HCl, are formed when 1 mole of methane, methane is CH4, 1 mole of methane reacts with excess chlorine, chlorine is Cl2, in the presence of sunlight? Now we know a reaction that is catalyzed by light, we refer to it in chemistry as a photochemical reaction. And we know the reaction between methane and chlorine in the absence of light or UV light is extremely slow. So, but when sunlight is present, the reaction takes place very quickly. We refer to this reaction in organic chemistry as chlorination reaction or substitution reaction. And the product will be CH3, Cl, and then HCl. So if you look at this, we will see here that when 1 mole of methane reacts with chlorine in the presence of sunlight, 1 mole of hydrogen chloride is produced. So the correct answer from the balanced equation here is option A, 1. Let's move on to number 11. Which of the following quantum numbers gives the number of orbitals present in each energy sub-level? The correct answer is magnetic quantum number. Remember, each energy sub-level. Let's look at, if I'm talking about energy sub-level, what are we talking about? We have 4 energy sub-levels. We have S energy sub-level, we have P energy sub-level, we have D energy sub-level, we have F energy sub-level. So the number of quantum number, that is the quantum number that gives the number of orbitals present in each energy sub-level. Now in S, there is only 1 orbital that is present in S sub-level. In the case of P, there are 3 because we have Px, we have Py, we have Pz. In the case of D orbital, there are 5 of them. In the case of F orbital, there are 7 of them. So it is the magnetic quantum number that gives the number of orbitals present in each energy sub-level. The correct answer for number 11 is definitely option B. Let's take a look at what number 12 has to say. Which of the following salts is an acidic salt? Now we know that we have 5 types of salt. We have normal salt, like sodium chloride. A normal salt is formed when all the replaceable hydrogen ion in an acid has been completely replaced by ammonium or metallic ion. We have basic salt, like an example of a basic salt is ZnOHCl, that's zinc hydroxide chloride. You can see that some of the hydroxide ion have not been completely neutralized by the acid. But the question here is asking us, which of these salts is an acidic salt? An acidic salt is formed when all the hydrogen atoms in an acid has not been completely replaced by either ammonium ion or metallic ion. And looking at the option, it is obvious that the correct answer is sodium hydrogen tetraoxosulfate 6, NaHSO4. Because you can see C, there is still 1 hydrogen here that is yet to be replaced by ammonium or by a metallic ion. So this is the correct answer, option A. Let's go to number 13. When phosphorus 5 oxide, which is P4O10, is dissolved in water, it forms dash. Now, phosphorus 5 oxide is an example of an acidic oxide. Even as the name suggests, an acidic oxide is oftentimes referred to as acid anhydride. Why do we call them acid anhydride? Because they can dissolve in water to produce either a weak or a strong acid. And when phosphorus 5 oxide, P4O10, dissolves in water, it's going to form an acid. Let's take a look. When P4O10 dissolves in water, it can form HP O4. If this is cold water, it can react to form HPO4. And to balance this, we can have 4 here, we have 2 here. HP, this should be 3. That's right. 4HPO3. So we can see 2 times 2, that's 4 hydrogen. Then phosphorus is 4, that's 4 phosphorus. Then oxygen here is 10. Plus 2 oxygen, you are making 12. 4 times 3, that's 12. So this is an example of a weak acid. However, if it dissolves in hot water, P4O10, if it dissolves in hot water, if this water is hot, then it's going to form H3PO4. And to balance this one, we have 4 here to balance the phosphorus. And because there are now 4 times 3 hydrogen, which is 12. What do we multiply by 2 to give us 12? That is 6. So we can see both this and this are acid. So the correct answer for this is a weak acid. After all, phosphorus oxide is an acidic oxide. An acidic oxide will dissolve in water to form an acid, either weak or strong. Let's look at number 14. Arrange the following gases in order of increasing rate of diffusion. We know that the lighter the gas, the faster the rate of diffusion. What we need to do is just, let's calculate the relative molecular mass of all the 4 gases. And then the one that has the highest value will diffuse slowest. And the one that has the least value will diffuse fastest. Let's start with H2S. H2S. Hydrogen is 1. 1 times 2, that's 2. Plus the mass number of sulfur, we can see, is 32. So that gives us 34. Going to NH3, nitrogen is 14. Plus hydrogen is 1. 1 times 3, that's 3. That will give us 17. Going to SO3, sulfur is 32. Plus oxygen is 16. 16 times 3 is going to be 48. Now, if we add this and this together, this gives us 0. That's 2 plus this. Then 1. Now, we now have 8. That's 80. And then finally, CO2. Now, carbon is 12 plus oxygen 16. 6 times 2 is 32. If you add that together, that's 44. So, if you take a look at this, we will see that this is the highest. So, this one will diffuse slowest. That's SO3. Will be less than. Next to that is going to be 44, which is CO2. Next to that is going to be 34, which is H2S. And finally, the one that is going to diffuse fastest is ammonia, which is 17, NH3. So if you look at the option, the one that is correct here that matches what we have on the board, SO3 less than CO2 less than H2S less than this, is definitely option C. So option C is the correct answer. Don't forget, the higher the relative molecular mass of a gas, the slower the rate of diffusion, and vice versa. So that's for that. Let's go to number 15. Which of the following carbonates decomposes on heating to give a black solid and a colorless gas? First of all, we should rule out option C. Sodium triisocarbonate 4 is thermally stable. It doesn't decompose when heated. It can melt and change from the solid to liquid from both. Remember, all carbonates of alkali metal, with the exception of lithium, is thermally stable. So, which means that, excuse me, if I tell you about carbonate of group 1 elements, carbonate like Na2CO3, carbonate like K2CO3, they are thermally stable. If you heat them, they don't decompose by heat. So, which means option C is ruled out. Then, if you consider option D, zinc, ZnCO3, when it is heated, it decomposes to form zinc 2 oxide and carbon 4 oxide. Now, zinc is not black because it says gives a black solid. When zinc is hot, the color is actually going to be pale yellow, and when it is cold, it is white. So zinc is ruled out of it. The correct answer here is copper, because when copper 2 carbonate COCO3 is heated, it will give copper 2 oxide and then carbon 4 oxide. Copper 2 oxide is black in color, and we know that carbon 4 oxide is a colorless gas. So the correct answer for this question is definitely option B. Let's go to number 16. A saturated solution of salt at 30 degrees Celsius contains 0.28 gram of the salt in 100 cm cube of solution. What is the solubility of the salt? So, this is a question under solubility. And we know that a simple formula for calculating solubility. We know that mole is equal to solubility times volume in cm cube divided by 1000. So, what we are looking for now is solubility. We have been given the volume to be 100 cm cube. What we need to calculate now is the mole. And we know that mole, our mole, is mass all over molar mass. The mass of the salt has been given to be 0.28. That's 0.28. All over the molar mass of the salt will be given the molar mass to be 56. That's 56. So, if you use a calculator to divide we have 0.28 divided by 56. That gives us 5 times 10 to the power minus 3 moles. So what do? We substitute here so that we now have 5 times 10 to the power minus 3 moles is equal to the solubility, let's represent by x, times the volume. The volume according to the question is 100 cm cubed, 100 all over 1000. What do? We can cross multiply. So 1 times x times 100, that is 100x is equal to 5 times 10 to the power minus 3 multiplied by 1000. That will give us ordinary 5. And then if you divide both sides by 100, x now is equal to 5 all over 100. So this one will give us 0.05 mole per dn cube. And if you look at the option, you can see that the correct answer is option A. And please don't forget to subscribe, to like, and to share our videos. And while you're at it, you can put on the post notification bell so that you'll be promptly notified when a new content like this is uploaded on our channel. Moving forward, let's go to number 17. The product. What product is formed when ethanol reacts with excess acidified K2CrO2O7? We know that acidified potassium heptaoxodichromate 6 is an oxidizing agent. And when excess oxidizing agent is used to oxidize ethanol, the ethanol, being a primary alkanol, is going to be first of all oxidized from ethanol to ethanol, and then from ethanol to ethanoic acid. So the correct answer here is ethanoic acid, option B. Please note that the question could be structured in such a way that the word excess here doesn't appear. You can ask question like, what product is formed when ethanol reacts with mild K2CrO2O7, mild, M-I-L-D. In that case, if the oxidizing agent is in mild form or in limited form, then the oxidation of ethanol will not be complete. Then the product will have been an alkanal, in this case an ethanol. But whenever excess oxidizing agent is used, there will be complete oxidation of ethanol all the way to ethanoic acid. So the correct answer for this question is definitely option B. Let's go to number 18. Chemicals produced in small quantities are called, we call them fine chemicals. Chemicals are divided based on the quantities in which they are produced. Chemicals that are produced in large quantities like H2SO4, all acids, salt, sodium hydroxide, and the likes are called heavy chemicals. But chemicals like drugs that we consume that need to be prepared with high purity and are produced in small quantity, they are regarded as fine chemicals. So the correct answer for number 18 is option C. Let's go to number 19. Which of the following halogens is most reactive? Halogens are located in group 7 in the periodic table. The first element in group 7 is fluorine, followed by chlorine, followed by bromine, followed by iodine, and then the radioactive halogen is astatine. And out of these halogens, the most reactive of them all is fluorine. As a matter of fact, that's one of the reasons why fluorine is never found free or in uncombined form, because of its high reactivity. So the correct answer for number 19 is definitely option A, fluorine. And don't forget, fluorine is also the most electronegative element with a value of about 4.0. Let's go to number 20. At 25 degrees Celsius and 100 kilopascals, most of the elements exist as, let's stop for a bit. 25 degrees Celsius and 100 kilopascal translate to standard conditions. All right, most of the time in chemistry, we say under standard conditions. A temperature of 25 degrees Celsius or 298 Kelvin is the standard temperature. A pressure of 1.01 times 10 to the power 5 Newton per meter squared or 100 kilopascal is called a standard pressure. So, at standard condition, most of the elements actually exist as metallic solid. Out of the 118 elements in the periodic table, most of them are actually metals and they are in solid state. So the correct answer is metallic solids. Let's go to number 21. A solute will not dissolve in a solution if the solution is saturated. We know that a saturated solution is a solution that contains as much solute as it can dissolve at that temperature in the presence of undissolved solute. So no solute will dissolve in a solution that is already saturated. So the correct answer once again for 21 is option C. Number 22. The compound ethene, that's C2H4, will undergo the following reactions except. So basically the question is asking, which of these 4 reactions on the board will ethene not undergo? Ethene will undergo oxidation. As a matter of fact, oxidation of ethene by acidified KMNO4 will produce ethane dioic acid or oxalic acid. The correct answer is dehydration. Ethene cannot be dehydrated. Ethene can be hydrogenated. It can undergo hydrogenation by reacting with 2 moles with 1 mole of hydrogen to produce ethane to become saturated. And also, ethene will undergo polymerization. After all, polyethylene is produced from polymerization of ethene. So the only reaction that ethene, which is the compound here, cannot undergo is dehydration. Option B. Number 23 now. A hydrocarbon with a vapor density of 28. So, vapor density is 28. And the hydrocarbon contains 14.3% hydrogen. So, the percentage of hydrogen is 14.3%. And don't forget, hydrocarbon is a compound made up of carbon and hydrogen only. So, which means there is going to be carbon present. The percentage of carbon will now be 100%. We subtract 14.3% from 100%. That becomes 100 minus 14.3%. That gives us 85.7%. And if you want to calculate what the formula will be now, we are going to divide this one, first of all, by the atomic mass. That's 1. And we divide this by the atomic mass, that's 12. So this one will give us 14.3. And if we divide this one by 12, divided by 12, that gives us 7.14. And then the next thing is, we are going to divide the two of them by the lower of the two. And obviously, it's the lower of the two. So we divide this one by 7.14, and we divide this one by 7.14. So 14.3 divided by 7.14 gives us 2. And this one obviously gives us 1. Now, the empirical formula is going to be C, that's 1C, and 2 hydrogen, H2. Now, multiply by N, which is equal to the molecular mass. Don't forget that 2 times vapor density will give us the molecular mass, that is, the relative molecular mass is equal to 2 times the vapor density. So, if the vapor density is 28 here, multiply 28 by 2, that's 56. That gives us 56. What do we do? We look for the value of N here. Carbon is 12 plus hydrogen is 1. 1 times 2, that gives us 2. Then N is equal to 56. Then this gives us 14N is equal to 56. If we divide both sides by 14, then our N now will be 56 divided by 14. That is 4. So N is equal to 4. So our molecular formula now will now be this. That's going to be CH2 4. Then if you use 4 to open the bracket, that becomes C4, then 2 times 4, 8. So the compound here is going to be butane. That's definitely option A, as can be seen here. Let's go to number 24. Which of the following statements about the periodic table is correct? A. Group numbers can be used to predict charges of ions. We don't need to go forward. That's the correct answer. Because every element in group 1, all alkali metals, have a charge of +1 on them. That's why we have Na+, K+, Li+, and so on and so forth. So, In the case of group 2 elements, the charge on them is going to be +2. That's why we have Be2 plus beryllium ion, Mg2 plus, Ca2 plus, and so on and so forth. For aluminium in group 3, that's why we have Al3 plus. So we can use the group number to predict what charge will be present on the ion, because an element in group 1 will lose 1 electron. That's why it forms a monovalent ion like Na plus. An element in group 2 readily loses 2 electrons to form a divalent ion. That's why you have Mg2 plus, and so on and so forth. So the correct answer here is definitely option A. Let's go to number 25. The product formed when ethane reacts with steam in the presence of a heated catalyst is dash. Now, when ethane reacts with steam, let's see what happens. When ethane reacts with steam, this ethane, C2H4, when it reacts with steam, we know that steam is water in gaseous state. In the presence of catalyst, it's usually nickel. Then what will be produced is ethanol, C2H5OH, which is ethanol. It is called hydration of ethane. So hydration of ethane produces ethanol. So as can be seen from the options, the correct option is option B. The product formed when ethane reacts with steam in the presence of a heated catalyst like nickel catalyst is definitely ethanol, option B. Let's go to number 26.